Hello, everyone, and thank you for joining us today. My name is Stephanie Riley, and I will be your host, and I'd like to welcome you to today's Oracle Advisor webcast titled Best Practices for Large Text-Based Content Repositories. Our speakers today are Cordell McGard, who is the Senior Principal Support Engineer, and Pete Olson, who is a Principal Support Engineer. We also have Kelly Severin, who will be a co-host and leading today's question and answer session. We expect today's webcast to last approximately 60 minutes, including a brief Q&A session. This session is being recorded, and at the end of the session, I will go over when and how you can access the recording and the questions and answers from today's webcast. Questions can be submitted to me throughout the presentation via the Q&A panel. Your questions will be collected and read aloud during the Q&A portion of the call in the order that they are received. To aid in better question collecting, please only submit your question once. If you are listening via voice streaming and lose sound, please go to Communicate, Audio, Broadcast to restart the streaming audio. Should you still encounter difficulties, please dial into the intercall directly using the numbers provided in your reminder email, which I've also posted in the chat window above. I've also entered any questions that remain unanswered at the end of the session will be transferred to the community where you can continue your discussion. Cordell, if you are ready, I can pass it. Sorry. What you are seeing here on the screen is a reminder that this is an advisor webcast, is intended for information purposes only. Any features or functionality described for Oracle's products remains at the sole discretion of Oracle. Now we can get started. Cordell, I can pass it over to you if you're ready.
Yep, I sure am. Thank you so much. All right, thank you everybody for attending today. We certainly appreciate it. I know we see a lot of repeat names that have attended these presentations, so we hopefully will give you some new information today. All right, our main goal of this, when Pete and I kind of talked about what we wanted to do for our next webcast, we kind of went back to a lot of the service requests that we've been getting, specifically around these large repositories. And what I mean by large are, several million items. We've had more and more customers lately been putting a lot of information into the content server, and they really kind of want some best practices on how to manage all of that content for various regions. So we're going to kind of go over these following items here. Understand what is a large text-based repository, improving the performance of those repositories, understanding how to rebuild the index, and then different tips and tricks that we have for you that will just kind of help with that. So if you remember, go back to the title of this. This is really designed for people using large text-based repositories. What we mean by that is typically Oracle text search. So for people that want full text search on their repository. Some of the items in here will benefit you if you're not doing full text searching as well too, just if you have 50 million items and you're doing metadata only searching, but most of this is designed around text-based indexing. All right, so we're going to kind of talk about some of the challenges that we have with these large repositories, some recommended architecture, sizing. We're going to talk about migrating and or what we call cloning, overview of the text index. We're going to talk about controlling the amount of text added to the index. We'll talk about rebuilds, which is a topic you're probably all familiar with. We'll talk about optimization, and then at the end here, Pete will talk about utilizing metadata-only search while maintaining Oracle text search, and then what an S-data field is all about. All right, so what challenges or what question or what problem are we actually trying to solve here by doing this? So we have customers say all the time, I want to add 10 million items to my WebCenter content system, and I want that to be searchable. Oh, and by the way, I want that all full text indexed. Well, with that come some challenges that we need to address if you're going to try to index that much content. And so, how did we get here to this point? Well, everybody continues to want to add more and more and more data to the system. And a lot of people like the ability to be able to full text search that data. But sometimes they don't really consider all of the possibilities or how large that index will grow by doing that. You know, if I say I have 10 million items and each of those documents have 2 words in them, you know, that's going to be a much different thing than if I say I'm putting 10 million PowerPoint files in, oh, and by the way, they're each 100 pages of PowerPoint. You can imagine how much text that would be, you know, relative. So the amount of items is not the only consideration. So keep that in mind as we go forward here. So what roadblocks might we run into? Well, disk space, obviously you got to kind of think about, you know, how large that's going to grow. Search performance is a big one, right? I want to be able to search the system and not have it be so slow. The database size or performance of the database itself. So along with disk space to store the content, we also have database size to store all of the text and all of the metadata as well too. And occasionally that can grow even further if you're storing all of the content also in the database, because that's an option for you too using our file store provider. So you could actually be storing, you know, that database size could get really, really large if you're not utilizing the disk space to store any of the content itself as well. And then rebuild times after adding a metadata field. So this is kind of a big one, is that, you know, I add a field, but I need that field added to the index, so I need to do what's called a rebuild to get that field added. And there is still some confusion over whether I need to do a full collection rebuild on that or what we call a fast rebuild. So we'll go over that in depth later on. And then the performance of loading all the content in, what we call indexing. So a big roadblock to this is really that initial load. So that's why we usually ask customers, you know, what's your ingestion rate and what will that rate be over time? So in other words, how much content are you putting in initially, and then once the system essentially goes live, how much more content are you going to continue to put into the system on a daily, weekly, monthly kind of basis, or kind of what's your projection? So along with that, then we kind of ask the questions really about all of the sizing. And this is typically done through our consulting services organization, but some of this bleeds over to support as well too. So we thought we'd mention at least it on the surface level here. So sizing is very complicated. When customers ask support, a lot of times we get these questions on, you know, well, how big of a system do I need, or how much database memory do I need, or, you know, they ask these what we think are very, you know, innocuous, very easy questions, but it's extremely complicated because of those items I've mentioned previously. Number one, like, how many items total are you going to put in? What we mean by items are, you know, content items. How many items per day, week, or month? How many users are you going to have? And then how many users simultaneously will be using the system? And then the big one is, you know, will the full text search be used? And so now along with that, we have to dig even deeper into that. And what I mean by that is just asking how many items is typically not enough. We need to know, you know, what those items are. Are these PowerPoints? Are these PDFs? You know, a lot of these large repositories are based on our imaging products. So they either use IPM, capture, combination of those things to ingest a ton of image files typically. And with those image files, sometimes they can do OCR and then extract the text out of that and then put that text into the index as well. For those people that are doing just straight imaging and they're not talking about, you know, putting a lot of text into the system, then a lot of these considerations aren't necessary for that if you're just putting in, you know, 10 million image files, right? Or 10 million files that you have no intention of ever full text indexing. Where we run into the challenges are when customers say, well, yeah, we're going to put in 10 million Excel files. Oh, and those Excel files each have 50 columns and 200 rows in each of them, and they're full of numerical data. So say you're an accounting firm or something like that. That's where that index can get very, very large. And we'll talk about that when we talk about what a token is. Because I just don't think that people consider some of those things long term. In other words, understanding that every single number is a new word. And so it can make your text index really, really, really big. And then the other consideration are, your storage options. Are you going to go straight database, or are you going to go file system? And there's no right or wrong answer to that. They both have their advantages and disadvantages, really depending on your specific architecture and your specific performance at whatever facility that you're putting this on, if you're doing this all on-premise. Now, obviously, if we're doing some of this with one of our cloud-based solutions, obviously that sizing is a lot different, right, because of the cloud sizing. So really what we're primarily talking about is the on-premise sizing here, that you're going to basically manage all of this. All right, so there's lots of tools that can make this discussion or these decisions easier. So Excel is a simple one, but it can do a lot of the calculations for you, where you plug a bunch of things in, and then it kind of gives you some general recommendations, right? Like how many CPUs you're going to need, how much memory, that kind of thing. And you answer just some simple questions, like average document size is what in kilobytes? Where's the storage at? Are you full text indexing it? How many percentage of the documents are getting indexed? How many metadata fields you have? So another big consideration that customers need to be aware of is that every time you add a metadata field, we have a flat metadata model in the WebCenter content world. In other words, if I have 10 million items, I'm going to have an entry. It could be null, but I'm still going to have an entry in every field for every content item in the system in our metadata index. So that's something to be aware of. I can't say, well, this document I don't want it to have this metadata field. It doesn't work that way. You set up a metadata field and it's going to go across every document. Doesn't mean that there's values input for that, but it means that you're going to have that field. So you'll see in a couple slides, one of the consideration is, do you absolutely need that field searchable? A lot of times the answer is no, and we can gain a lot of performance by turning that off. All right, are you doing a webless file store? And then how many requests per second, kind of what's your peak? And then here's another example, right? So then we can say, initial number of documents, how many documents per month, how many revisions per month, how many deletions per month, percentage of documents with thumbnails, converted to PDF, those different things. Folders, that's another big one. And then you can kind of see, the initial size and how big that's going to grow, really, to kind of tell you how much storage you might need if you're going to do that straight on the file system instead of in the database. All right, so the next topic I want to talk about is really just this concept of migrating large systems. So we get this a lot in support with customers that have, let's say they have 6 or 7, 10 million items on a system, and they say, hey, we want to copy that to another system. And it might sound easy on paper, but you can imagine how long that process would take if you're copying 10 million items over to another system. So there's a number of tools we can use to do this process. So Archiver and CMU are our two that support has been talking about for years, really since they were invented. But then we also have this concept of this copy config, or what we call cloning, and how we clone a system. And then we use this copy config and this paste config to do that. However, there's some challenges with that. And performance is a big one. It's going to take a lot of time, and then especially if your text index is very large. And so there's some other considerations as well, too, when you're doing that. So here's some tips for that. So if you have the Vault and the web layout directory outside the domain directory, right, that's the recommendation. And the reason for that is the Vault and the web layout will try to get put in one large file, one large zip, essentially. And so by doing that, you're trying to, zip up that much content because you're trying to zip up the entire vault, you can see how that could be problematic. Or if you store the content in the database, that can help with that as well too. And then doing those make the T2P, we call it, is test to production is the real official word for it. The clone migration, then a viable option. Otherwise, the only supported means to migrate content is to use the archiver, which works, but if anybody's used the archiver, you know that it's slow, and that typically the support question is, how can I make archiver faster? So that's typically the, what customers kind of want to know is how best to do that. All right, so let's talk a little bit then about the text index itself. Excuse me. So it helps to understand where the text information is at, because then when we're dealing with these large repositories, you can understand to talk to your DBA, you can understand what they want to be looking for and the size of things and where things are stored. And because typically questions that we get a lot of times from DBAs are, hey, my database just grew by 76%, when they put all this content in, and they said that they're not putting the content in the database, they said that they're putting the content out on the file system. So why is my database, growing so large so quickly? Well, the answer to that is usually in these tables here. So these tables are the Oracle text tables, and these can grow very, very, very large depending on how much full text information that you have. So that's why I thought I'd give an overview of what these tables are. So they're listed there as the $I, K, N, R, and S tables respectively. This came right from one of my 12C systems, so you can see it there. Yours will look very similar to that. All right, so what are the tables for? Really kind of, what the main ones. Well, the $I table is the main one that we want to be considered when we're talking about these text repositories, and that consists of all of the tokens that have been indexed to that point. And we'll talk about more what a token is in a little bit. The K table is an index organized table, which just maps the internal doc ID values to the external row ID values. So that's all in internal. And the R table is really just the opposite from the K table. And then the N table contains a list of the deleted doc ID values, which is then used and cleaned up by the index optimization process. So K, R, and N are really just internal ones that you don't really need to worry about. They're kind of self-managing. But the I and the S ones are the ones that we talk about most when we're talking about things like optimization and the size of the text index, etc. And so the S table, the $S table, is specific to how the table was created during the create index step, and in which in our case is going to represent your S data fields. And so Pete will be talking about S data fields later on, but that's what's in that $S table. All right, so what's a token? What do we mean by token? Well, the easiest analogy of is really a word. But it's not necessarily a word. It can be more than that, but that's the easiest way to think of it. Because numbers can also be tokens and, other things, characters, etc. And the Lexer's job, so the Lexer is part of Oracle Text Search, and its job is to split all of that text into tokens. And so the easiest way, I think, to explain it is really just to use an example. So if you see that example down below, you have a sentence, aha, it's the 5:15 train coming here now. That actually would get split up into words minus the punctuation and special symbols, and this is what would actually get put into the text index. So you'd have the sentence down below that's kind of split up. So notice how the number 5 and the number 15 are going to be thought of as two separate tokens here. And so we can split all these up, and then that's what gets entered into the system. To give you some example, the entire English language of a dictionary has, a couple 100,000 words, right? If you took every unique one and counted the unique values of the English language. We've had people into the hundreds of millions of unique tokens in their index. So just take a moment to understand that. Hundreds of millions of unique words or unique tokens. So you can imagine how large then that index is. And you might be thinking, well, how is that possible? Well, every number is a unique token. That's one way that it gets very, very large. All right, so what's a stop word? Because stop words kind of go hand in hand with this whole lecture idea and this token idea, etc. So a stop word is really a token that's not indexed because you typically they're unnecessary in terms of searching. In other words, I'd never really search for the word the. It just doesn't happen. Typically in the English language, people aren't going to really search for the word the. I don't want to find all the documents that have that word in them. So it's useful, the stop words are useful in limiting the amount of text that's actually indexed. And there's a default list of stop words. So for example, that same sentence would actually likely be indexed, depending on how your lecture rules are set up, would be indexed as the following on the bottom down there. So how does this pertain to really managing or best practices of these large text-based repositories? Well, you can probably see where we're going with this, and that is by understanding a little bit how the tokens are established and understanding what's getting inserted, you're better able to limit the amount of information that you're putting in and optimize it as well. So the next topic here is what fragmentation is. So fragmentation is where too many rows are used for the single word in the $I table, causing that table then to grow very large. Ideally, you'd like to see a single row per word. And fragmentation just happens naturally over time as documents are added. So here's an example right from my system. I checked in the same document that said the quick brown fox jumped over the lazy dog. I checked it in a bunch of times and noticed that that token brown is appearing multiple times in my $I index. So this is what we call a fragmented index. Now, it's not very fragmented, but it's still fragmented. The word brown is being repeated here over and over and over again. We can see I purposely left a couple other words there that aren't being repeated, and so those are nicely optimized words instead. So really what we'd like to see is that we'd like to see one row with the word brown, and then over here there's some columns you can't see, but it would tell me how many instances of that I would actually have. And so that helps control it. So that's when we get into what's called optimization. So if you're going to take anything else away from this presentation and you have a large text-based repository, you absolutely need to be doing optimization on it. And optimization really is the defragmentation or optimization of that index. So it's taking all those browns in the previous example and removing all of the rows but one, and then just adding the count instead. And you can see how that can greatly reduce the size of that index then. And here's an example optimized statement that you'd want to run. And if you follow that document ID that we linked there at the top, it goes over this in more detail. So if you want to jot that one down or look at it up on the slides later on, feel free to do that. All right, so the next tip or the topic we're going to kind of delve into a little bit here is really just in relating to controlling the amount of text. So it kind of goes back. I had to kind of give you the history of what tokens are, what the index is, where that's stored, give you that history so you can understand how to ultimately strip down or trim down those text tables to make them faster, better performance, etc. So why do we want to limit it, right? People say, disk space is cheap. Let's just fill it up with everything. I'm not going to ever do any optimization. I don't need to. Well, larger repositories in general require more maintenance. That's just kind of a simple rule of thumb because you'll have a longer rebuild time. You'll have slower searches. You're going to have to optimize more often. So I wrote a series of notes, and one of them is this best practices for using Oracle text search and controlling the size of the text index. And inside that note has several topics and how to do it. And you can do any one or all of them that are mentioned in the next couple of slides here. So number one, controlling the amount of text simply by turning off certain metadata fields that you don't need to be searchable. We've found support over the last 10 or 12 or 15 years in support here that customers tend to set up a lot of metadata fields. 200, 300 is not uncommon. However, most people or their end users rarely, if ever, search on those fields later on. So they're finding that they're putting a lot of full text information in the system because every metadata field goes into the index if you check that box that says enable for search index. But yet we find that people never search on those fields, or very rarely. Maybe one person out of 1,000 would ever do a search on that. Most people search on some key things: authors, titles, and then just full text in general. They typically just like to type into a box because they're very used to things like Google, and they want to just hit one box, type their thing, and have it search that. So a lot of times they're having a lot of these fields that they don't need added to the index. So one of the simplest things to do is simply uncheck certain fields from being indexed, and that can save a lot of space. Another thing to do is to limit what file formats that you're indexing. So you can skip Excel files, for example, or any number of different formats. You can say, I don't want to index PDFs for whatever reason, but you can do that. Also, file size. You can say if somebody puts a 300 megabyte PowerPoint in there, I do not want to index that thing because it's just too large, or checks in a dictionary, or checks in the entire contents of Wikipedia. We don't want to do that. And then we can also do different indexer rules and different stop words. So kind of going back to those stop words, if your question is, hey, can I add my own stop words? Absolutely. So if you have a company name, for example, and you don't think anyone's ever going to search on your company name within the documents in your company, then you can imagine how many times that company name is appearing in your index. So you could add that as a stop word, and that won't be indexed. All right. Next thing is really about this concept of rebuilds. So rebuilds kind of are, a big support issue for some customers that have to do very large rebuilds on very large systems. So I want you to be aware that there's two main types of rebuilds. There's a fast rebuild, and as you see, I put fast in quotation marks there because it's not really fast in terms of if you have a very large index. It still takes time. It's just faster than doing the full rebuild, but it can still take several hours, days, weeks, depending on your performance of your system. So a fast rebuild simply uses the existing index and it adds new information to it. So like when you add a metadata field. So when you add a metadata field, you do not need to do a full rebuild of that collection. What a full rebuild is that's reprocessing all of the content. In other words, every time you check a document in, we process that through outside-in filters using a thing called text export, and we scrape essentially all of the text out of whatever document that you are putting in the system. That's part of our normal, what we call indexing process. Well, when you hit the full rebuild thing, you're doing the re-index of all that content again. That's why those full rebuilds can take so darn long. So when is a rebuild actually necessary? Well, when you add a new field, you still have to do a rebuild. When switching search text, so if you go from metadata to full text, or if you get some index corruption. So we're going to talk more about the corruption piece here in a little bit. All right, so what are some ways to increase these rebuild speeds? Well, number one, only do the full rebuild when absolutely necessary. And if you ever question that, open a support ticket and we can help you understand if there's a better way around that than doing a full rebuild. Reduce the amount of text content to improve it. Parallelism, which is to basically add a parallel degree to some of the processes like sync index and optimize, etc. And then changing the batch size can help rebuild as well too. The amount of batch size is the amount of content that hits a checkpoint when you're going to then do the index and do the sync. And then how do we release content while you're rebuilding? Well, there's a setting called allow concurrent update equals true that you can turn on that will allow, while you're doing the rebuild, new content to continue to get indexed. Customers ask that question all the time. So what happens when a rebuild fails? Well, that's kind of really the last part of our thing here. And that is we're going to talk about this concept of we have a system, we've done the rebuild, but the rebuild, failed. So we can still search during that collection rebuild. So the collection rebuild always occurs on the inactive index. So normally searches work as expected. However, what if the rebuild is being done because the active index is actually broken as well too? So you kind of have the worst case scenario here. So with a corrupted Oracle text search index, searches aren't returning the expected content, expected items are missing, items not meeting the search criteria, and then new items won't index. Old content may still be searchable. So this is where I'm going to turn it over to Pete now to kind of talk about some tips we've done to kind of make this process a little bit less painful. So.
All right, thanks, Cordell. Hi, everybody. The follow-up on this slide, a corrupted search index. One obvious sign that your index is corrupted is new content won't index at all. The index just aborts, or searches return like a DRG or an OR error. But there are other signs that your index is corrupt. You do a search and you get your items that you're expecting are just not getting returned. I mean, if you know that they're meeting the search criteria, or just the opposite, that you're getting items returned that you know aren't meeting the search criteria, like you go into the doc info page and it's got different metadata field values, or a text isn't in that particular items. Or again, new items won't index. Old content may still be searchable, but you just can't get anything else to be indexed. Or just the opposite, that new items will index and you can search them, but you can't search the old items. I think I have to be made presenter.
I did.
Ah, there we go. Okay. So what happens if your active index is corrupted, that searches just aren't working correctly? Now, the reason we're putting these slides in and we're discussing this is a few months ago, Cordell and I worked with a customer who had this situation happen, that their active index was corrupted, and it was going to take about a month for them to complete the collection rebuild. So we came up with a means that they could actually still do searches. And that was to search against the doc meta, the documents, the rev classes, and the revisions table. And we do that by using a select statement. And this is an example of that. And then you can see in one of the lines, you have the and D is primary equal 1 and the D release date in Y, U, and I. That's just to indicate these are released content items. Now, when we have a parameter that you can set in the config CFG file, search index or engine name equal database.metadata. So that's what that parameter actually does. It actually runs that select statement. Now, database.metadata searching. Now, as I mentioned, you can set that in the config CFG file if that's what you always going to do as your search. However, if you set that in the config CFG file, you won't be able to rebuild the Oracle text index. So, in order to be able to get metadata, database.metadata searches to work, in the get search results service that we use when you do a search, we can actually add in the search engine name equal database.metadata parameter. And below is an example of the URL. So you see the get search results, and then we have our query. And then you'll see in there highlighted in the red the ampersand search engine name equal database.metadata. Now, configuring for the database.metadata searching. For searches on the content server itself, we can create a global rule. You can also do this through a profile. Now, you'll see here that there's actually technically a typo in that little bullet down there. For all of you non-native English speakers, that actually should be a specific search instead of an. It's just one of those things that makes English such a goofy language. So we can do this as a global rule, but you can actually add this into your own search profiles that you already have. So in order to be able to do this, the next bullet point, for external applications, you can add that parameter into the get search results parameters. Now, when you're doing an external call, like you're doing a SOAP request or a RIDIC call, rules and profiles don't get invoked. So you have to actually add that into your parameter string. And we have a KM note on how to configure for this. And I'll actually do a demo on this right now on an example. So to do that, I will go ahead and share my screen. Okay, and then just to show you the rule.
You don't have it.
Oh no, I've been locked out. There we go. Okay, so we go into the configuration manager. And then we'll go to our rules, and there's my rule. I know this might be just a little hard to see. And then we have a rule activation, the do it on search and on request. And then we have our, this is when it gets invoked. Now if I look at the side effects, it's the side effects that will actually do this. So you can see at the side effects, we add in search engine name equal database.metadata. Now to show you what that will look like, I'll actually go ahead and do a search. Now I had that set as a global rule, so no matter which search profile I use, that'll actually get invoked. So I'll do the search from there, and then from this other browser, we'll look at the trace audit. Okay, and there we are. So now we'll go ahead and do, now when you're set for database.metadata, you can see that these are all the standard database.metadata search operators. So we'll do a start, and we'll do it on test. And there's my search results. If I take a look at the trace, we'll go down and find my get search results, which is right here. And then if we take a look, you can see that we're doing a DDoc title like test. You can see what we convert that into an Oracle, well, to a SQL like. And then you can see the search query is right there. You can see it's doing the select statement. And that's how we're getting our searches. Now, to show you, as I mentioned, that this is doing it as a rule, and rules don't get invoked when making external calls. So I'll show you the example, and I've been using SOAP. So I've got SOAP UI, and in this case, I'm using one of the content server search WSDales. And you can see that in there, I've added in the parameter here. It's a search engine name database.metadata. So let's go ahead and launch that, and I've got my search results. If we go back to my view server output, we'll go find my get search result. There it is. There's my get search results. again, that's my operator, and that converted to, again, to the DDoc title like. And then again, you can see there's my select statement. So let's go back to our slides. There we go. Okay, now doing database.metadata searching, the pros and cons. Well, the pro, of course, is as your index is being rebuilt, you can still do metadata searches. And you can continue to check new items in, and you can search for those new items. Now, the con is, of course, it's database.metadata, so that you will not be able to search for text within the content. And the other issue is searches are case sensitive. That's how it is with Oracle database. Now all this database not metadata would apply if you're running SQL Server. And the advantage with SQL Server is it can be configured to be case insensitive. However, for Oracle database, as we're case sensitive doing metadata searches, one option is to create option lists for your metadata fields so that you always have a fixed value. So instead of having the user type in the search value and not knowing whether it should be uppercase or lowercase, they can just pick from the option list drop-down menu where the item or where the value is always fixed. Now, the last portion of the presentation is we're going to discuss S-data sections. Now, if I was on Who Wants to Be a Millionaire, and this was like my $100 question, I would be done because I really can't explain it. I know what it does and what it's for. So these entries are straight from the Oracle Text CTX documentation. So the value of an S-data section is extracted from the document text like other sections, but is indexed as a structured data, also referred to as S-data. Using S-data section supports operations such as projection, range searches, and ordering. It also enables S-data indexing of section data such as embedded tags and detailed table or function invocations. That's really a cool way to put that. This enables you to perform various combinations of text and structured service searches in one single SQL statement. S-data tokens are contained within in our case, they're stored in the FT_IDC text number $S table. Now what I can explain is how S-data sections relate to content server. We use them as like a metadata field's own self-contained index. So when you are checking in items, the value of a metadata field, if it's set for an S-data section, will actually be added to the S-data $S table. Now by default, all data integer fields have an S-data section. So when you create, you're in Configuration Manager, you create a date or an integer field, it automatically will have its own S-data section. We can set accounts for their own S-data section. And then other fields can be set as S-data sections going through the Configuration Manager. Now, in regards to having a large repository where this ties it in, this can help, in some cases, improve your search performance. So why do we use S-data sections? As said, we can improve search performance. Using those can reduce the amount of tokens added to the $I table, which, as Cordell said, that's where all tokens from all fields and text gets placed. S-data sections can retain special characters in the tokens. So this is one of the reasons why we use it for a date field. So you have a date like 11 August 2017. I have no idea why I used that date in particular. if this was placed in the $I table, and Cordell had that shown in a previous slide, this would actually break it into 3 tokens because the $I table won't retain special characters. So we'll have 11, we'll have AUG, and 2017 all as separate tokens. In an S-data section, 11-AUG-2017 is just 1 token. Another example would be like the DDoc name, like you're using a prefix with an underscore. If you're using a DDoc name S data section, that would actually be retained as WCC underscore, in this case 1, 2, 3, 4, 5, 6. That would just be 1 token. Another reason we use S data sections is it keeps numbers from being added to the $I table. If you ever look at the $I table, and you can do this in like SQL Developer and Toad, you'll see that you'll have lots and lots of numbered tokens. And the more rows that you have in the table, the slower your searches can be. So this is a way to help reduce the numbers getting added or integers from being added to the table. That's why we set integers as data sections. If we have field values that all have the same prefix, middle, or suffix value in the string, we can keep that from being broken up. Again, that previous example where I had WCC underscore 1, 2, 3, 4, 5, 6. So if we have something like that where we have a commonality, then we can use the S data section for that. Another reason we use it is, and this is a very common error, is the DRG-51030 wildcard query expansion resulted in too many terms error. What does that mean? That means that there were so many rows in the $I table that were included in that wildcard that it just exceeded the limit within Oracle text. Well, you will typically see this when you're doing contained searches with numbers in them, like a test data 1 or WCC underscore 1, or if you do a wildcard search on that, like you add a percentage to the 1, there could be just so many tokens that start with WCC underscore 1 or have 1 in them that you'll generate that error. Or if you do a has word prefix, again, that's when you're doing a wildcard search, like WCC percentage. Like if you had that as your DDoc name prefix, you would get, and you have millions of items, you would get that error. We also see those with accounts. If you have accounts with very long strings, like you have many sub-accounts. Because when we search on accounts, we always search accounts as wildcards. So we can generate that error if you're using accounts. Now, how to configure for S-data sections, we have 2 KM notes that cover how to do this. One is searches fail with error DRG-51030, the wildcard error, and how to search WCC metadata fields as S-data sections. Now, in both of these KM notes, I believe will mention that if you're running Oracle database 11.2.0.3.0 or lower, there's a set limit of 32 S-data sections. So if you need to increase that, we have a KM note on how to do that. Basically, it's to upgrade your database. Anything above 11.2.3, well, 11.2.0.4.0 and higher allow for further S-data sections. Now, how to search with S-data sections. We search date and integer fields automatically, and you can see that in the search query trace. For accounts, we can set a parameter to do case-insensitive account search equals false. For other fields, you do a matches search. And this is an example of doing a matches search on the DDoC title. You can see where it's going to search it as an S-data section. Now, even though you're doing a matches search, you can still do wildcard searches. You would just add the wildcard, like the percentage on the front or the back of the term that you're doing the search against. And with that, my section of the presentation is complete. Now, when we said demonstration, that was actually the portion that I showed you on setting the search engine for the database.metadata.
Awesome. Thank you very much, Pete. So we'll just do a quick summary of what we covered, and then we'll open it up for some questions. I see a couple chat questions that we have, and so then we'll go through it from then. All right, so awesome. So what did we cover today? We understood kind of what a large text-based repository was, how to improve performance of those repositories, how to rebuild the index, and then some tips and tricks we covered at the end. Now what we've done is we've also kind of compiled some of the KM notes that we went over. We've kind of compiled those at the end here for you on this last slide as well, but they were throughout the slides as well. All right, just some quick notes about our social media and staying connected and the different communities we have as well. So with that, I think we're ready to open it up for some questions.
Okay, Pete, Cordell, I can finish up.
Great.
We're waiting for a question. I see David posted that there is a component for case-insensitive search, and we use it. Yes, we actually had a standard component. It was like the do case-insensitive search component, and we had that all the way up through 10G. And what it did is it changed all your search operators and values to upper. And the reason we stopped using it is it was a performance hog. When you use upper or lower in a query string, it can really reduce search times. So that's why we stopped or no longer added into as a standard component. But if you have it and you use it, great. Or if you come up with your own custom component, that's great.
Okay, we're going to open it up for Q&A in just a moment. You can use the Q&A panel or the phone line to ask any questions. You can send the questions via the Q&A panel on the WebEx screen, or you can press *1 on your phone. While we pause to collect some more questions, I'd like to share some useful information. We'd like to invite you to stay connected with Oracle support via the various social media channels listed here. We have the Oracle communities where you can post your questions and converse with subject matter experts and peers from other companies. My Oracle support blogs where you can keep informed about our priority announcements, as well as Twitter and Facebook. The link you see here is for today's webcast to continue the discussion thread. The question and answers from today's webcast will be posted to this thread, as well as responses to questions that we will not be able to get to today or during the webcast. Please use this thread for any follow-up questions you have related to today's topic. To easily keep track of updates to the thread, you can use the following in link on the top right portion of the screen to add this thread to one of your MOS community streams. Selecting the inbox link from the upper right-hand corner of the screen will show all streams you have created. You can also choose to bookmark or like a particular thread. I'd like to go over how you can locate the recording and Q&A from today's webcast. You can start at document 740966.1. It's just starting place to find out about upcoming webcasts or get the recording, PDF, or continue the discussion links for all webcasts. From the drop-down page, you will select your product area of interest. Here you'll select Oracle Fusion Middleware. When the page opens, you will be able to see all upcoming webcasts on the Current Schedule tab. For today's webcast, you will select on the Archive 2017 tab. You can click on column headings to sort, hover on webcast title for more information. If you have any questions on the webcast, ask questions via the question mark link. Recordings are available within 48 hours. Okay, so now we can open it up for questions. Again, to ask a question, you can use the Q&A panel on the screen, or you can use your phone by pressing *1. So, Andrea, can I start on the phone and see if there's any questions?
Yes, ma'am. And at this time, there are no questions.
Okay, Kelly, I think there's a few in Q&A if you want to start there.
Sure. I believe you addressed David's question, so I'm going to move on to the search engine behind works fine, but for the end user, the search interface and way of displaying results matters. The expectation is something similar to SES.
Sure. We're not sure if there's a question there, if that was just kind of a statement, I guess. Maybe they were asking about, is there a way to have a unified search repository? Because I see earlier David asked a similar question, revolved around that, which is kind of the whole unified search thing. So we used to have the product, the SES, the Secure Enterprise Search, which would allow you to search across multiple repositories and then display the results in one unified fashion. The product is still there, but we don't have it any longer as a strategic product or whatever you want to call that. We're basically not shipping it out any longer, but some customers are still using it. What most people have done is really kind of created their own front-end interface and then just used various mechanisms, APIs, to then search across those repositories. Now, one other method that people do when they do have a lot of searching to do is we can split off the search index separate from the rest of the database, meaning that you can have the search repository on its own database, essentially, and it uses then a different provider from the database to search it, not just the system database provider. So if that's something that interests you, there is a note on how to set that up, but basically it's just a disconnected or a separate search repository. It's in the install guide on how to set it up. Also, we have some notes on doing that as well, too. That's really useful if you're going to be doing a lot of searches, and that's your primary consideration, and you don't want to combine your search index with all of your metadata, essentially.
Okay, great, thanks. And actually, there was also a follow-on to that. Is there any plan for enhancing the search interface module of WCC?
Sure, yep. So the latest content UI is really the replacement for the entire user interface. So a few years ago, we released what we call the content UI, or other people refer to it as the ADF UI, and that's really the enhancement for the user interface for the entire product. And so that's the new improved, basically, search interface as well as just the normal user interface.
Okay, great, thanks. And can you back up search index and restore in front of index corruption?
Yeah, you bet you can. If you know how far back the restore from, you certainly should be able to. Now, a catch to that, of course, is say new items are still indexing. So if you restore, of course, those items would no longer be in the index. So you might have to resubmit those items. You could do that through Repository Manager or through Archiver.
But Pete brings up a good point. For some customers, it's actually quicker to do the database restore than to do the full rebuild. So that's another option, right? So when I said make sure that the full rebuild is basically you've exhausted all the other possibilities, the restore is one of those other possibilities. Sometimes you can go from a 3-week rebuild to a 1-day database restore, and all you have to do is add all the items in that were checked in after the restore.
Okay, great. Thanks, guys. I have one more question in the Q&A panel. Stop words versus DB reserved words. Are SData fields searchable on just stop words or DB reserved words as well?
That's a good question. If you place I do believe that stop words and reserved words cross over. So if you have a reserved word or you add a stop word, then those will not get indexed within the SData section along with the normal $I table.
Okay, and I actually just got one more. If do we have time to do one more?
Yep.
Yeah.
Sure
Yep.
do.
I also have another
Okay.
one, so we can keep going.
Okay. Is there a calculator for determining how long a rebuild might take?
Sure. So it's kind of a tricky question in that we can't calculate it before. However, once you've initiated the rebuild, it's pretty easy to do the math. In other words, we have a lot of customers that have done previous rebuilds, and they said, you know, number one, they took X long, and number two, once they've kicked it off and they see it's done, let's say 10,000 documents in an hour, then we can simply do the math because based on the relative thing. The tricky part is if we don't know what your content is, we won't have an exact idea of how long the whole thing's going to take. In other words, if the first 10,000 documents it encounters are all very, very, very small text documents, but then the next 10,000 it encounters are all very large PowerPoints, it's going back to that whole thing. If you're doing the full rebuild, you're going to re-scrape or re-extract all of the text out of those documents again. So you need some idea of if your content is generally the same across your whole repository. But unfortunately, we can't calculate it before you click the button.
Okay, thanks. I have one that came in to my Q&A panel. Before we get to that, Andrea, is there any questions on the phone at this time?
No, ma'am, there are no questions at this time.
Okay, so it looks like the last question we have then is there any way to know that WCC is not using the Oracle Text Index?
Probably the best way to know what you're actually searching against is to go into the system audit trace. Set it for request audit, search query, and system database. Go ahead and run your search, and then go into the view server output page, look for your get search results string or service, and then take a look at the search query string and the system database parameter. That will show you which search you're doing it against. You'll either be doing it against the, running a select statement, or you'll be calling our result set content server procedure.
Now, at an even higher level, if they're simply asking, what is my system configured for, they can simply look either inside the config CFG or on the admin server page under the general configuration, or even on the configuration for instance page, and it'll show them exactly what they're configured for. So it's really two answers to the same question, essentially. If I simply want to know, am I set up to do Oracle text search, on the configuration page is the quickest. It'll say engine name OTS on there for Oracle text search.
Great, thank you very much. I will leave the webcast open for a few extra minutes. If anyone has any other questions, again, please submit them and we will get answers for those and post them back through the community thread. As of now, that concludes our Q&A portion of the session. Thank you for a wonderful session. I'd like to thank everyone for taking the time to join us today. We hope you found the webcast valuable. Please take a moment to share your feedback on the presentation and the webcast program via the survey that will display when you exit today's event. Let us know what topics you'd like to see covered in Webcast Futures. Thank you, and have a great rest of your day.